So if you try to connect the dots, so first we started with the course content. So what are the stuffs we'll be discussing in this particular big data course? Okay, forget, don't think like it's only just Spark thing. A lot of other things we are also discussing. So first we discussed about what are the major topics we'll be covering. Big data is vast, like in India itself, like there are a couple of NITs, they have big data specializations, just like data science and all. So if there are a lot of topics are there, so there are a lot of contents are there. So we first narrow down like what are the contents we'll be covering during this 60 hours of program, and then we discussed like what are the type of projects we will be executing. So some people are from different people are from different backgrounds. Some people are from software development background, some are from data analytics, some are from DevOps.
Your voice is breaking.
Is it for everybody? Is it breaking?
Now it's better.
Yes, I see some background noise.
Yeah, background noise.
Is it like fan voice or fan noise or something else? Just give me a second. Yeah, I think it's
fan.
I think now it's better.
I think it should be better now, right? It's better now, right?
Yes,
Okay.
yes, now it's better.
Yeah, just feel free to interrupt me if the voice is not coming properly. Okay. Yeah. So what I was saying, like your question is basically how to basically connect the dots. You're saying like you have a lot of theory things. You have gone through the Spark's official documentation site, or like you went through a couple of videos on YouTube from different contents like Databricks or Spark Summit and all.
Yeah.
And now you have a confusion like how basically we are learning the stuffs, like what's the how we are basically connecting the dots. We are doing hands-on, sometimes we're discussing theory part, but how to basically connect the dots. So one thing is basically, as we are discussing, like unlike just like any other framework or technology, language and all. So the traditional way is basically you first build your theory, like what are the concepts behind, or what are the at a very granularity, like what are the theory part. First, you build your understanding about the distributed computation, Yarn clusters architecture, and Spark's RDD, then Hadoop framework, Hive. So you first build some basic knowledge on all this, and then you specialize in one thing. Say suppose your multiple big data frameworks are there, then you started learning Spark specifically. And in the other way, so in the other way around, like if you just connect the dots from the day one till today. So first we discussed about the course contents, like what are the contents we'll be discussing during the 60 hours. So of course, what we are saying, like the content is vast. So some colleges are taking 2 years of master's program on big data. You can imagine like how much time you have to spend there. That I feel like that's for the students level people, like who are directly who are fresh graduates and they want to go into data engineering. So you can basically again wait for 2 years and you can learn the stuffs, and that's good. Like it creates a base for you. Like I sometimes feel like if colleges include all this stuff, data engineering, visualizations, data science, everything in the bachelor's degree itself, then life will be easy. Like you don't have to learn again everything from the scratch once you get into a job. That's what currently happening, isn't it? We learn a lot of theories, operating system, compiler design, then what do you call then C programming, C++, which is like in the industries, people less than 1% of people are using those programming languages. So we are learning those things, and we are entering into corporate. We are working into some companies. We got a placement, and then we saw it's completely different stuffs we are learning. Of course, the backend like data structure algorithms, these are there, but majority of the things you are learning from the scratch. You thought of like starting your career in data engineering or data science or cryptocurrency like blockchain and all. So you saw like there is very less relationship with what you have learned in the past in the college, right? Yeah, that's what, like if colleges have all these things, means you can imagine like it's a 4 years degree. In the first year, say some programming language like Java, C++, then some programming languages, And in the second year, maybe data structure algorithm. Third year, maybe data engineering. Fourth year, maybe fourth year, maybe data engineering, data visualizations. Fourth year, maybe data science and all this. So in this way, what will happen? No, in this way, what will happen? No, so you have to. So life will be easy. Like once you get a job, so you already have some background, then you can basically improving your knowledge to how to use that knowledge in real time projects, right? But unfortunately, that's not the situation here in India. Most of the colleges, not a single college, have all these things. I'm not sure. I think this. I saw in my previous company, people were some colleges. It was kind of very small institute, and they got converted to college. They are including all these stuffs, but majority of the big colleges, they still go on the previous version, like most of the theoretical part, and then once you get into job, then you have to learn everything from the scratch. Kind of those 4 years you didn't efficiently use your time. So anyway, like let's not go into details. Coming to this course, like how I have organized the stuffs, we can think in this way. First, we discuss like out of this vast content, what are the topics we are covering in this course. Then the question comes in like why you are giving that content. Is it because of your own convenience and all? Yeah, that's true. That's one of my own convenience, and it's also relevant because I'm working in the companies, like I'm working in startups. I have executed multiple projects single-handedly end to end. So and also like in bigger projects also I've worked with bankings and so other some CPG companies. So where there are bigger projects, like in a project like more than 5-6 people are working. So in this case, what happens like we are already aware, like in the companies, in the projects, what type of tools and technologies we are using and what are the type of projects. Okay, so that helps us like narrow down the broader content. In the colleges, they will start with the, again very scratch. Even if you go for big data specializations, they will start with the distributed computations. They will take one semester on that and all this, and then will start with the some basic programming. By the time you leave, by the time you complete, you have some basic knowledge in the big data. But here it's completely placement oriented. Means honestly like that's the end goal everybody has, right, in their mind. So how this course will help you cracking interviews easily and quickly. That's my whole intention. Some people give me bad rating in my Google review because of this only. This guy is only focusing on the placement and all. So that's feasible. See, like in 60 hours, you can learn that much. Okay, and trust me, like you will only learn the stuff once you start working in projects. Otherwise, you will hear the things and you will forget it. You see, like I'm asking questions, how the people are not even responding. Means I'm not sure, like why you are not responding. I'm pretty sure, like you are not going through you are not recapping, so that's why you are not confident. But things will happen in that way. So that's why, like if you, so that's why we learn by doing. Like you have some programming experience now, you will do hands-on at least some 100 examples in this course. Now you have end-to-end knowledge. Like means if somebody is asking like how to set up a new project or how to do this kind of transformation, once you get into a company and a person, your lead is saying just share your screen and just do this analysis for me, I need these reports. So you will be comfortably write those codes. So that level of preparation we are doing. Okay, so coming to that, like that's how I just organized the course content. The course content is sufficient enough to crack interviews. Okay, in fact, many people are clearing interview. Yesterday, 3 people got offer. Means if you're following me on WhatsApp, so there are 3 people got the offer like in the same day. Okay, so every month, at least 4 or 5 people are clearing interview. Okay, what more you want? Like every month, I also take a batch of like 10 people, 10, 12 people, and every month means without my help, only through the course only they are cracking. At least 5 people are cracking interview here in India, not about the US. US is a different story, but here in India itself, people are clearing interviews. Then you got into some project, then you slowly start learning the real time stuffs, and you build your base on that. Okay, that's how basically I organize the course content to help you quickly and easily crack interviews. And post that, you saw like what are the type of projects we execute. Okay, so you are from different backgrounds. Some people are from testing background, some people are from scripting, DBA, then ETL, data engineering, software engineering, multiple backgrounds. So you already have seen some projects. You must have worked with some clients. That client may be financial client, maybe CPG client. Some client you have already worked on. You have seen some projects. Then how those projects are different than data engineering project that we saw. Okay, so means it shouldn't be like you are there in the mindset like I'm doing DevOps thing, these are the stuffs, and I'm learning a new framework. So how it will basically help me here, isn't it? So those things to build that perspective, we started discussing around the type of projects you execute and the projects what you are working, and after getting into big data, you will be also working for the same clients. You are currently working with some bank, you are currently working with some CPG company, you are currently working with some startup like some IoT companies. So end of the day, you will be also working for the same companies, but the type of projects you'll be working is different. Okay, and it's not completely different. Some similarity you will find in terms of project stories and all, but but the type of projects is completely different. This is that things we discussed, and post that we also discussed. We just executed sample programs to basically show you, like, to give you some glimpse, like how the life will be like once you get into big data profile. So at a daily basis, what type of work you will be doing, how you'll be writing the code and all. So those things also I show. I just showed you. Okay, slowly we will again build more specialization. We'll start writing more complex programs and different other types of programs to build your programming base or the hands-on. You will get the proper hands-on to work on the projects. Okay, so that's how basically, and again, and for that we'll again keep on discussing more and more examples. We saw just a very small example, and similarly there are a lot of different type of tricky data transmission problems are there. We'll be solving all those kind of programs. There are more than 150 examples. Okay, I think which is more than sufficient. Every type of question you will face in the interviews, and it's there in your laptop. You must have executed. If you're following the sessions at a daily basis, you will be for sure like you have all these programs in your laptop, and you have tried those things once at least. And then basically we will wrap up the entire course through a project. It's a very small project, and it's again a real-time project. You will see the entire perspective, right from the data ingestion, data curation, data processing, everything you will see in a single application with the automation part, everything. Okay, so that's the whole agenda. Okay, that's the whole agenda. That's how you can quickly learn. Like in 2 to 3 months, you can learn the stuffs, and you can get into this, and then you have whole your career. Like you can spend another 3, 4 years, 5 years to basically get your mastery on this. And then once you have like enough experience on this, then you can go to the next level. Maybe you want to go to data analytics, data science, or like you want to, means people generally keep switching their profiles. Yeah, every 5 years, 10 years, we should keep changing, otherwise life becomes boring. But as some people make their career in one thing forever, that's also there. Like some people are going into very specialization level, that's also there. Okay, so that's how basically I'm just trying to connect the dots. Okay, so, does that answer your question, or you still have some confusion?
No. Okay.
Okay, so yeah, means it really means I really like this kind of questions. So intermittently we should take a pause and we should connect the dots. Otherwise, what will happen means as and when like you keep on progressing, you're forgetting the previous steps. So why we discussed that and how we executed those. So those we basically keep forgetting. Okay, so anyway, so what's the assignment? Anybody remember? I think some data set we have given, and we were doing some analysis on that, right?
Yes, that one finance data set.
Okay, and one finance data set. Okay.
Yeah, basically calculating the amount of each customer.
Okay, so let's upload the data. Did you create your workspace and all, or? So it's the data folder. Which file you are seeing? I think transaction factory. This one, right? Let's quickly read this file and see. just read the data and let's see how the content is, how the content look like. Dot should take 5. Let's see how the data looks like. Okay, so we can see this data is having first line as the header, transaction ID, create time, amount, customer ID, status, merchant ID, some payment processing data. Okay, so it's a transaction data, and you can see the fields are delimited by pipe, right? All these fields are separated by pipe, right? So anybody remember what's the question is basically? Is it to find the total amount for customer?
ID.
Yes.
Yes, correct. So cool. I think Rohit just pinned the answer. We can make use of that. I'm also a little lazy, and people who are putting effort, they should be getting appreciated. Can you copy this code and paste it here?
Yeah,
Aman?
but
Mhm.
but in the last, when I add some, I haven't got the result. I think there is no same customer IDs. When I went through in the CSV file,
Okay.
I can't find any 2 customer IDs or multiple customer IDs.
Okay, you're
So,
saying for every record, there's a different customer ID, is it?
yeah, exactly. I thought that I found
Okay,
it.
okay. Okay, that's fine. If it is there, then there. Okay. So, okay. So what you have done, so transaction RDD is equal to spark context.text file. You read this file as a RDD. Then you applied the filter transformation and to remove the header, and you have written a function, a predicate. It's a function which returns true or false. And then you basically created another RDD by removing the header. Okay, so this function takes a record which is of type string, and this function returns a boolean, right? So for now, let's keep all these things. Let's write all these things. I think some indentation issue. Then basically we remove that header. Where is the indentation issue? Okay, here. Okay. So post that, once you did the once you remove the header, then we splitted all these records through pipe. Okay, we first split each of these records through pipe. You saw the records are pipe delimited, and then we extracted the second, means third field and fourth field, right? Third field and fourth field are I think some problem is there. Okay. How was the data looking like? Let me quickly see this. Okay, 0.2. 2 is amount, 3 is customer ID, right? So we should have like done in this way. Key should be customer ID, that is 3, and value should be amount, that is 2. Okay, so let's see how the data looks like. Customer and amount. Yeah, now we are seeing customer ID and amount. Then basically we can do aggregation. Yeah, this is how the data looks like. So each and every customer ID along with the total sum of transactions. Okay, I think some, like at least 1 or 2 customer IDs are duplicate, otherwise most of them are unique. It's a bigger data set. I just taken a small portion. Okay, so yeah, anyway, like we'll discuss that in more details. Before that, let's first start building our understanding on what is RDD. Okay, so we have discussed, we wrote a program without understanding the details about the RDD. We directly jumped into programming. But now today, let's first see like what is RDD. and then we'll try to connect the dots. Okay, we'll try to connect the dots, like how we have written the program and what are the different concepts used in different lines. Okay, so first thing is basically what is RDD. Okay, that's the first thing. What is RDD? So the definition of RDD is, first of all, the full form is, I think everybody is aware now, resilient distributed data set. And the definition is, so we discussed like while working on the program, we were like saying it's just a huge collection. Okay, we have already used list, set, dictionary in different programming languages, and we are saying RDD is also a similar kind of, it's a huge collection. Okay, collections used to be residing in one computer's memory, because in the traditional programming languages like Java, C, C++, everywhere you create an array, list, or any collection that resides, like when you are executing the program, that resides in the RAM of the same computer. Okay, if it is Java programs, in the JVM's heap memory, that data resides. But here we're saying it's a huge distributed collection. You are now working on a distributed environment, multiple computers, tens or hundreds of computers collectively processing your data, isn't it? That means, so tens or hundreds of computers are collectively processing your data. So that means what is happening here. So that means your collection is not residing in a single computer's memory, rather it is residing in multiple computers' memory. Okay, if you go in details, so there's a lengthy description or definition. So it's a fault tolerant immutable distributed partitioned collection of JVM objects. Okay, so this is basically the definition of RDD. Basically, it's a fault tolerant, immutable, distributed, partitioned collection of JVM objects. Collection, we know, like list, set, dictionary, or map. These are all collections. These are all collections you have seen in programming languages, as well as these you have seen in the programming languages, as well as database also. Like you can create a collection, you can create a column of type list or basically map and all this. So it's a collection, but we are saying it's a collection of JVM objects. Why this? What's this fancy word? JVM is nothing but Java Virtual Machine. Okay, and you must be aware, like all these frameworks, like if you know, if you started exploring around this. So Spark, when the application is executing on a cluster also in the backend creates whole bunch of JVMs, Java Virtual Machines, to execute the application. Okay, so don't think like we are learning Java here, but things are inherited here. So Java is, you write a code like .java file, you compile it to bytecode, and those bytecodes are executed on top of Java Virtual Machine. The moment you install Java or JVM, so on top of that JVM platform, your code get executed. Okay, and you know Spark is a framework which has been created using Scala language. Scala is also a JVM based language. Scala programs are also getting executed on top of JVM. You first need to install JDK and then you install Scala. Okay, directly Scala doesn't exist. Okay, that means what you understand, like Scala gives you a separate setup interface, separate setup libraries to write the program. Java also gives a separate set of libraries to write a program, but both of them compiled to bytecode, and bytecode get executed on top of JVM. So it's a fundamental programming, right? Means any programming language, once you write a program, that program will be compiled to a compiled version, and then the compiled version will get executed. It's two-step process. Same thing, same story. So both Scala and Java project applications get compiled to bytecode. The compiled version is called bytecode, B-Y-T-E, bytecode, C-O-D, bytecode, and those bytecodes run on top of JVM. Okay, that means entire Spark framework has been created using Scala language. So that means naturally these are all running in the backend on top of JVM. And here we are learning Python. That means what? All our code getting converted to bytecode through the Spark framework itself. The library is what we are using. These will also be converted to bytecodes and it will be executed on top of JVMs. And the cluster what you're using, you will see like here the database, you also saw we created a single node cluster. This cluster will be running your will be executing your application. Okay, how it will be executing your application? By creating different containers or JVMs. Okay, slowly start building your vocabulary. Like we will be using this kind of terminologies while working in data engineering projects. Okay, we will be working on this. We will be using this kind of terms frequently while discussing about the projects or working on the projects. Okay, so the cluster itself is a software or it's an application which has been created in such a way that every time you submit a Spark application or Hadoop application or Flink application or Hive queries or Pig script, any big data related code or application you submit, it will execute it on top of whole bunch of JVMs. It will create multiple JVMs and all on those JVMs, the code will get executed. Okay, these JVMs are called containers or executors. They are all one and same only. It will create a whole bunch of executors or JVMs or containers on top of which your code will be executed in a distributed fashion. Okay, so that's why like all this data what you are processing, you are reading and doing the processing, these should be JVM compliant. JVM should recognize, should understand those kind of objects, isn't it? JVM should understand or recognize those objects. That's why we are saying collection of JVM objects. You are residing in Bangalore, so you are a Bangalorean. Another person is residing in US, so you are a US citizen. So that means like base is the place we are you are staying, you are called as that. So similarly, we are saying the data what you are reading, the data points, these will be executed in the backend like on top of JVM only. That's why we are calling these are JVM objects. Okay, so basically it's a collection of JVM objects. It's nothing different. It's all these are JVM objects only. We create integer, string, boolean, list, map, everything is JVM compliant already. Okay, so it's a collection of JVM objects, and then we are saying it's distributed. It's distributed. Why? Because we discussed last session. So traditionally, you were solving this data engineering problems or data analytics problem on top of traditional systems like Informatica or like different warehousing infrastructures like Microsoft SQL Warehouse and all this, right? But since the data size is increasing exponentially, so single server based systems won't be able to process this. Okay, you need to create a network of computers. Okay, you have to cluster out multiple computers and you create a bigger computation unit on top of which your code will be executed. That's why we are saying it's distributed. Your application will be distributed, or it will be divided into smaller tiny tasks. Okay, and those tasks will be executed will be executed on different JVMs on different machines. Will be having different JVMs, and your data will be residing on that. The moment you read or data and you create a collection, your collection is now not a contiguous collection. It's a broken, it's a splitted collection. Okay, you have a billion record, and each split may be say 100,000 record. Okay, so each split is 100,000 record, and you have 10 computer. That means you have set up a cluster of 10 computer. So each computer say hosted 3 JVMs. So that means each computer is processing 3 or 6 or 9, any number of partitions, and it's running. It's basically storing the data in that way. Earlier, when you are executing the application, the entire data was getting loaded to the RAM of the same computer. But now here this huge giant collection is loaded to the RAM of hundreds of JVMs or tens of computers. Okay, suppose you have created a 10 computer cluster and each computer has 5 JVMs. So that means you have total 50 JVMs. So 50 JVMs are now storing the data in bits and pieces in the RAM. That's why we're saying it as distributed. Okay, the data is distributed across the RAM of tens or hundreds of computers. And then we are saying it is partitioned. So it looks like these are one and same, only distributed and partition, but there is some difference. So distributed, you are saying your data is distributed across 100 computer or 1,000 computer. Partition is your data is again further partitioned into smaller pieces. Say you have a billion record data set and you just decided to keep the number of partitions as like each partition say 128 MB. So say on an average, say you got 1,000 partitions. Okay, you got 1,000 partitions, but you have only 10 computers to store the data. That means each computer is having 100 partitions in the RAM. Okay, this is a collection. We are saying it's an in-memory collection. So what we are saying, you have a 10 node cluster, 10 computers or nodes. These are one and same only. 10 computers clubbed together as a single cluster. On top of that cluster, your code is getting executed. On top of that cluster, your code is getting executed. Okay, so that means your data can be of 10 partitions. In that case, each computer is holding 1 partitions. But if your data is 100 partitions, that means each and every computer is having 10 partitions in the RAM. If the data is 1,000 partitions, that means each computer is having 100 partitions in the RAM, isn't it? So that's what. So each and every computer is having more than 1 partitions in the RAM. That's why we are saying it's a partitioned collection. Then you might be wondering like why we are basically keeping the number of partitions more than the number of computers. These questions naturally will come. Okay, and I'll be really happy like if you can ask those questions and you're like I'll be discussing for sure. But what you attentively just listen, and then once you build your foundation, it's fundamental. Then life is very easy. Like all programs, you will be able to visualize how the backend is getting executed. And in all interviews, people ask about the optimization techniques and all. You will be able to better explain them. Okay, so then what I'm saying, like it's distributed. Your data is distributed across hundreds of computers RAM, and each computer can have 1 partition or more than 1 partitions also. It depends upon the programmer how you want to achieve how you want to solve the problem. Okay, so there are a lot of things are there. We will be discussing. It will be difficult to discuss now because it will create a lot of confusion. But think in this way, like you have a huge giant collection. That collection is broken into multiple smaller partitions, and each computer can have 1 partitions in the RAM or multiple partitions in the RAM. Okay, each partition is nothing but you again think like this is again another list. This entire RDD is a list of list. You can think in this way. Your list is you have a billion record, and that one RDD represents that billion record. That means this RDD is a list of list, you can say. Okay, a list having smaller or tiny sub lists. Okay, and each list is nothing but a partition called. Okay, your RDD is a outer or a bigger collection, bigger list, and it has smaller list, and this smaller list are called partitions. Okay, think in this way. Okay, it's a distributed partition collection of JVM objects. You have 10 computers and you have billion record. You have decided 1,000 partitions. That means your data is distributed across 10 computers, and your data is partitioned into 1,000. So each computer is having 100 partitions in the RAM. Okay, then we are saying it's immutable. It's plain English word, something you can't change it or you can't modify it. That's called immutable. Immutable means you won't be able to change or modify that data. Okay, immutable means you won't be able to modify or change that particular data. So once you create a RDD, you won't be able to modify it. That means like how will we applying transformations? We did a lot of transformations in the previous examples, right? But we are saying here it is immutable. So immutable means once you create a RDD, you won't be able to modify it. Every time you are applying a modification or transformation, in the backend, it creates a new RDD altogether. That's why it's called immutable. You created a RDD by reading that billion record. That's a RDD having say 1,000 partitions. Then you applied a transformation, say you remove the filter, remove the header. That's also a transformation. Then you splitted each record through tilde or pipe, and then you extracted the required fields. That's also a transformation. Every time you apply a transformation, you end up getting a new RDD altogether. That's why we are calling it as an immutable collection. You created means done, means Spark will not be able to modify it. It will not give you permission to modify it. Every time you apply a modification or transformation, you are transforming the data from one format to another format. In the backend, you are creating a new RDD altogether. You are creating a new RDD altogether. That's why it's called immutable. Then fault tolerant. Fault tolerant, as the name suggests, like means it's unbroken. Means it's not. Once you create a RDD, it will never be inconsistent ever. Okay. Once you create a RDD, you won't be able to. Once you create a RDD, you won't be able to. So Spark will not. Spark will not be able to like corrupt the data. In the sense, like we are saying, our data is stored or distributed across 10 computers and it's 1,000 partitions. And we have discussed like in the backend, all these files are stored as three replications, and the partitions are by default 128 MB. Right? All these concepts we discussed. So you're saying it's fault tolerant means like when you are writing some program and executing in a cluster. So what happened? Like few nodes went down, 2 nodes went down. So does that mean the RDD what you just created out of this billion record? So you will be losing those 2 nodes data, and your RDD is now having say some 800 million record or 700 million record, and now your RDD in an inconsistent state? No, it will never ever happen. Okay, so Spark has abstracted all these things. That's all about the Spark framework is. Okay, their core white paper was RDD only, resilient distributed data set. They spent years to create this data abstraction. Just like integer is a data type, list is a data type, RDD is a new data abstraction or a new data type, you can say. So Spark project is nothing but they first started with this framework. RDD, and that's what we are discussing. This RDD is nothing but their core part, and they're saying it's fault tolerant. Even though few nodes went down, still you won't be losing any data. Okay, in the worst case, your code will fail. That means giving some error like not enough memory to store the data, few partitions lost. Those kind of exception will get, but it will not silently just remove the data and it will give you the half or partial RDD, partial data to you. It never happens. It's very much fault tolerant. Then how Spark achieves fault tolerant? Spark achieves fault tolerance in 2 different ways. First thing is obvious. We are seeing the data we read from a distributed file system, say HDFS and all. So when you read the data from a distributed file system, the distributed file system itself is saying your data is 3 times replicated. Okay, it's saying like the data itself is 3 times replicated. Okay, the data itself is 3 times replicated. So that means your data is having say 100 partitions. So 100 partitions is actually in the backend 300 partitions, and each of these replications are stored in different nodes. So if few nodes are going down, so Spark will read the other copies from other machines, and it will make sure the same RDD is intact in the meantime. Okay, that's how basically this fault tolerance means. Okay, Spark has completely abstracted this from us. In the backend, if your nodes are going down, it will manage how to read the same data from other copies from other machines. Okay, that's one point about the fault tolerance. And the second point is basically at the job execution model. Okay, fault tolerance, we're saying first one is basically at the file system level. Second one is basically at a job execution model. We'll discuss job execution model in like almost one session completely. So that's very important. But right now I'm just giving a very high level overview. So applications, these are not like plain programming languages like C++ and all. It works in a completely different way. You create an application, you submit it to the cluster. So the cluster will create a unique identifier for the entire application that is called application ID. And that application ID will be broken into multiple jobs. Okay. So one application will be broken into multiple jobs. Each job will be broken into multiple stages. Each stage will further be broken into multiple tasks, 4 level of granularity. Every time you submit an application to a cluster, you did the development using your local computer, using PyCharm and all. Then you build it as a jar file or it's a Python application. You just take out that entire application folder and keep it into the master nodes file system. And then you execute the Spark submit command. We'll do that multiple times. So when you do that, when you execute the Spark job on the cluster, it first registers a new application ID. That application ID will be broken into multiple jobs into stages into tasks. Okay, and Every time Spark finishes one stage, it just write the output of the stage into a file system in the cluster, not into HDFS, because of the obvious reason. If it stores into HDFS, it has to copy 3 times. All these things will there, but it's temporary data, right? It has to be deleted post the job execution completed. So the output of each stage is physically written to the temp directory of the cluster. Okay, so that means when a stage fails, okay, so we are saying like application, job, stage, task. So when suppose your one of the job is broken into 10 stages and say 7 stages broken, will it start from the 0th stage again? No, it will not, because it has already persisted the output of previous stage in the file system. So it will read the data from the previously failed, previously checkpointed location, and then it will start doing the further stage processing. Okay, that's why basically that's why it is called. So that's how basically Spark achieves fault tolerance. Okay, it's very common interview questions. Okay, you go to any interviews, like if a person is getting into Spark, if the JD has been mentioned explicitly on Spark, for sure these questions will be written. Difference between RDD data frame, what is RDD, and all these things. Okay, fault tolerance means this. Once you create a RDD, it's really a fault tolerant. It will never be half or partial. It will be the entire RDD or not at all. Your application will fail. Okay, it will never give you a partial RDD. Okay. That's right. So we are saying RDDs are, so what you're saying, like RDDs are fault tolerant, immutable, distributed partition collection of JVM options.
Siddharth,
Yeah, please.
yeah, one question I had, like, I was going through some documentation where I got like, in RDD they say that internal final computation is always done on RDD. So what is this internal final computation?
Say that again, please.
Internal final computation is always done on RDD. So what is the meaning of that? Like, what is the meaning of internal final computation? Like, what it means?
Hence, you can think in this way, like doesn't matter whatever data abstraction you use. Spark has not just RDD, it has data frames, and if you're using
Yeah.
Scala, there is data set is also there. So
Hmm.
all these data abstractions are backed by RDDs only. Because as you are discussing, the white paper is RDD only. The Apache Spark's white paper is nothing but it's RDD only, resilient
RDD.
distributed data set. On top of that, they have created different wrappers like data frames, data sets to make our life easy, to further
Okay.
simplify the APIs. That's why they're
Okay.
saying like, it doesn't matter which data abstraction you use, these will be all executed in the backend by RDDs. One second. Got my point. So that's the reason because of which they have mentioned like that. So it doesn't matter whichever data abstraction you use, always it will be executed in the backend in terms
Okay.
of like RDDs.
In the terms of RDD. So like we can assume like it's a kind of a stack, like with RDD sitting on the bottom, and on the top of RDD we have data frames and data sets, but every computation will be done in RDDs only.
Exactly.
Okay, okay.
And all
And
this execution model, what we discussed, no? It's
yeah,
application
yeah, yeah.
ID, job, stage,
Jobs.
task. These are all you will be seeing on the resource manager page.
Okay, okay,
Okay,
okay.
so that's the definition of RDD. So just by head this syntax, by head this definition. Again, because as I mentioned, like in double quote, this we are mostly focusing on cracking an interview with real-time experience. So don't think and just say like I would say just remember few sentences I'll ask you to remember. Just remember it. So you can think in this way. There are thousands of applications you can develop. We are say developing 100 applications here. I would say just understand it and by head it also. Because an interviewer asks some questions, you directly write the answer. Don't just say, let me Google search, let me search the API and all. So it creates an impression means you don't have enough experience, you are doing it recently. So that's why just remember it so that without looking at Google, you can directly type the code. Okay, that will help us. That will create a positive perspective as if this person is already using Spark since multiple last 4, 5 years, 10 years. Okay, like that. And then the next question is how to create RDDs. Okay, how to create RDD. Okay, so let's try to connect the dots. First, we discussed about what is RDD. It's a fault tolerant immutable distributed collection. So we created one RDD here, transaction RDD. Cleansed RDD is another RDD. Okay, customer ID RDD is another RDD. Transaction count RDD, this is again another RDD. We have created multiple RDDs. Then the question is basically how to create RDD. There are only two different ways you can create RDDs. One is basically by reading data from external sources, and two is by applying transformation on existing RDDs. Okay, so there are two different ways you can create RDDs. Okay, there's only two different ways. There is no third way. It's always two different ways you can create RDDs. And okay, so that's basically how this thing happens. Like what we are saying, this is we are saying by applying transformation on existing RDDs and by reading data from external sources. And we have used both in the code. Okay, let's try to connect the dots. So we are saying by reading data from external sources. Here you read the data from external sources. Okay, Spark context or text file, and you specified a URL. And this URL can be a file setting on your SDFS or a file setting on your any cloud storage like Amazon S3 bucket or Azure blob storage and all like that. You can read data from any systems. You can read data from file systems like distributed file systems, cloud storages, okay, like that, and create a RDD out of it. Okay, so that's one is first one is basically reading data from external sources. So this is a text file you are reading. So you can read pretty much any kind of data. Okay, so this data set what we discussed, no, this data set you can think of anything. Okay, it can be structured, semi-structured, unstructured. These are the three type of data sets you'll be seeing in your projects, but honestly, like 99, not 99, 100% of projects you will see only structured or semi-structured data only. So structured data are nothing but the data is having a proper structure. Like you are reading data from any RDBMS like MySQL table, MS SQL Server table, Oracle table, any database table you read the data from. These are all structured data. Structured data means so your data is basically whole bunch of records, and each record is having a fixed schema. Each record is having a fixed schema. So if you just open the file, yeah, please. Somebody saying something?
We can also read data from parallelize, right? Using parallelize.
Yeah, parallelize is a function that's basically we will be converting a standalone Python collection to RDD. So that is also there. Okay, but
This
yeah, that's
as an external sources.
Yeah, that also you can say external source. That means where Python collection is an external source for Spark. You can think in that way.
Okay.
For example, you just read this credit transaction data. So this is called structured data because you can see each and every record is having a fixed number of fields. Okay, each and every record is having a fixed number of fields. That's why this is called structured data. The data is having an inherent structure associated with that. Each and every record is having 4 fields: account number, amount, date, category. So you can see this is the account number. Okay, this is the account number. Then amount 1.23, right? Then basically the transaction date, and then the transaction description. Okay, like that. So each and every record is of same structure. There, that's why we call it as a structured data. Okay, the data is having an inherent structure. That means if a field is missing, then it will not create a 3 fields, create 4 fields, but that field will be filled with null. Okay, NULL, null value. Null means nothing. Okay, so these are called structured data. The data is having always structure. Okay, and you know, like enterprises always store their data in a structured storage. Have you ever heard like Flipkart is storing their transaction data in a flat file? No, those days are gone. Like 30, 40 years before, people were doing that. But now everything is on database. Okay, the data is having a fixed schema or a structure associated with. Okay, so that's really, since we are working on enterprise projects, not like research projects and all, so that's why we'll see like all data are basically both either structured or semi-structured. Okay, either structured or semi-structured. Then you open another semi-structured data, say company JSON. Okay, this you can say this data is, it's called semi-structured data. Semi-structured data as in, you can say this is also having a structure, but the structure is not very strict. Okay, you have heard about JSON file. So here you can see each and every record is a JSON document, is a JSON tree. Okay, so tree as in, I'll show you in this way. You can see this data is having a tree-like structure. Okay, company is having a names and new company. Employees, it's a list of, again, nested element. List of elements, each element is having two attributes, first name and last name. Okay, first name and last name, like that. It's a list of employees. Similarly, you take another record, say last record. Last record is not having employees. So here you see this data is having company as an element, employees is an element, first name is an element, last name is an element, like that. And then when you replace it with this, here you can see first name, last name are not appearing, only company and employees. That means this data doesn't have a very strict schema. It has a schema for sure, but it's not very strict. So you can say employees are optional. So that's why you can see employees are empty list, and the list has no first name, last name. Okay, and that's why it's called. That's why it is called like. That's why it is called like kind of semi-structured data. Okay, the data is having some structure, but not very strict. Okay, these are also very popular these days. All NoSQL databases you are hearing about, MongoDB, Cassandra, then all these databases like NoSQL databases, they work on this model. They have not a very strict schema. They have a schema, but not very strict. Okay, so these are semi-structured data. Okay, these are semi-structured data. Okay, structured and semi-structured data. So since you are working on enterprise projects and enterprises always store their data in a structured or semi-structured format, so 99.99% of projects will be working only with this kind of structured or semi-structured data, no unstructured data. Unstructured data are for machine learning applications, like you're doing some text mining. Okay, you are finding out some pattern inside text, topic modeling, and all those. Those are ML machine learning related projects. But in enterprise applications on data engineering projects, you will never ever see those kind of data. Okay, because those data doesn't exist, because companies always store their data in some databases. It's a RDBMS or NoSQL database. Okay, that's why it will be always structured or semi-structured data. Okay, so that's what I mean basically. So how to create RDDs? You can read any kind of data. You can read both structured, semi-structured, or unstructured data and create a RDD out of it. Okay, and you have different functions. Okay, use a Spark context.text file is a function to read a text file. It doesn't says that you have to read always a structured text file. You can read any structured, semi-structured, or unstructured text file and create a RDD out of it. Okay, so then after that you will see sequence file. Sequence file is again another file format. Then new API, Hadoop file. A lot of things are there. Hadoop file. And later in data frame, you will see very popular file format in the projects we always use called Parquet file format, Arrow file format, okay, JSON file format. All these things will be using there in data frame. You can read directly a database table also there in our data frame. You can read a NoSQL database. NoSQL database. There it is called document. Okay, you can read a NoSQL document. All this kind of data you can read there in data frames. But here in RDD, so these are the couple of file formats: a text file, sequence file, NUK Hadoop file, and also there is another function called parallelize function. Parallelize function is basically used to convert a standalone Python collection, Python list to RDD. Okay, all these things are there. So that's the first approach. And second approach is, and we have already seen in the code also, we have seen most of the things. You saw like we read a text file and created a RDD out of it, spark context.txt file, and we have provided this, and then we are creating a RDD out of it. We'll discuss what is SC also. Slowly I'm trying to connect the dots. So text file is a function to read a text file and create a RDD out of it. Okay. Similarly, we have sequence file, parallelize, and all these functions, and we'll see them all, okay, one by one. And the second one is basically by applying transformations to existing RDDs. Okay, by applying transformations to existing RDDs, you can create. So you can see everything is interrelated. Right? So in the RDD we discussed like data. So RDD is immutable. Okay, we are saying RDDs are always immutable. That means once you create a RDD, you won't be able to modify it, isn't it? Once you create a RDD, you won't be able to modify it. That's what is, or that's what is called as immutable. Your RDD is immutable. Now, you're saying that every time you apply a transformation, you create a new RDD. And while discussing about how to create RDD, we are saying this is also one of the things. Okay, this is also one of the things. We are saying RDDs are also you can create by applying transformation to existing RDDs. You read a data and you create a base RDD. Then you remove the header, you filter the header and you create another RDD. Then from the filtered or the cleansed RDD, you apply transformations to extract maybe a couple of fields. Each record, that's what you created another. Then you applied some aggregation, that also created another RDD. Like that, in this way, it keep on creating new RDDs. Okay, every statement, every transformation you applied here. Here you have applied filter transformation, you created a RDD. Here you applied map transformation, you created again another RDD. You applied reduce by key transformation, you created another RDD. Okay, like that, every time you apply a transformation, you created another RDD. Okay, that's basically how to create RDDs. And then the next thing is basically so all these things we have already discussed, like we discussed like map function, filter function, by key function, all these things we have seen. Next thing is basically how to apply transformations. How to apply transformations on an RDD. Okay. So nothing but these are the functions we have seen. And many more functions we will see, but not just limited to this. Aggregate by key. Like that. It goes on and on. Okay. So all these different type of functions are there. These are called transformations. Okay. Now let's try to connect the dots, like what we did, what we discussed about the definitions and different type of functions and how it is related here. So we saw like what is RDD, and this is applicable to all these three RDDs we have created here: transaction RDD, cleansed RDD, customer RDDs, and transaction count RDDs, and all this. And then let's go more details. In first line, we said transaction RDD is equal to spark context.txt file. I'm expecting some good questions. Try to participate. Don't just listen; it will be boring. Initial few sessions until we get into proper programming. So Tausif, you are good, right? Or you have any queries? Rohit, Ram,
No, Siddharth.
Adim. Feel free to interrupt me, okay? Because anyway, end of the day, you will be paying for your course, so nothing to like hesitate, or you don't need to feel shy like other people are. say asking a lot of things I'm not able to ask, but you slowly start asking questions. Trust me, like if you start participating, it creates a lot of interest, and it doesn't matter whoever, nobody sees, like from the day one only, we never turned on our video, right? We never came in front of the camera. Who knows? And you are all people's name are appearing on the first name. You can't, nobody can even search you on LinkedIn, isn't it? So there's nothing to feel shy. Okay, means nobody knows you. Okay, we are completely like different individuals. Even if we don't know, a person is sitting there in Bangalore, or somebody is sitting there in Canada or anywhere, right? Nobody knows anybody. So nothing to nothing to feel shy. Nothing bad in asking questions. Okay, means if you ask a question, it will immediately clarify your doubt. Otherwise, it will keep on means piling up multiple doubts, and like after a certain time you'll feel like no, it's really boring, or I'm not able to understand it. Okay, I'm repeatedly saying, okay, means end of the day it's your own course only, and it's a live interactive session. So, and I have enough experience, like I think like I should be able to answer your questions, most of your questions. Feel free to ask questions. Okay, because you are now learning for the first time, so this framework is a right time to ask the right means all questions. Okay, so the next thing is basically what we are discussing. Like let's first discuss the first question, first line, that is uh, I'm sorry. Okay, so basically what I'm saying, like first line is basically Spark context. First Spark context or text file. So Spark context is again a variable. You can see like you didn't create, but it was already there earlier. This is how we create variable, right? So you say x equal to 10 or y equal to hello world. That's how we create variables, isn't it? So now we are saying text RDD is equal to Spark context dot text file. Okay, Spark context is an object that is having all these functions. Okay, it's again a variable. It's pre-populated. Every time you create a notebook, not just Databricks notebook, there are different other notebook environments are also there. Databricks, then Zeppelin notebook. Okay, then yeah, these are the major two notebook environments are there. So basically when you create a a notebook, so by default, and you attach a cluster to that, so Spark context object comes by default. Okay, and Spark context object is nothing but it's the entry point to the Spark functionality. Okay, the entry point to the Spark functionality. Okay, it's the entry point to the Spark functionality. And right now, I think this is the right time to go to the Spark documentation side. So if you search like Spark doc, or Spark's documentation site. So in the API documentation site, so you can see like we'll discuss that in details. So you can write Spark using all these 4 languages. You can use Scala, Java, Python, R. So here we are learning Spark with Python. So I'm going to Spark with Python here. And then they change the look and feel here. Spark documentation site. API reference. Let's go to API reference. What it is saying. So Spark context object is the main entry point for Spark functionality. A Spark context represents the connection to a Spark cluster and can be used to create RDD and broadcast variables on the cluster. Okay, so what it is saying, Spark context. So you saw like you didn't create a separate type of file and all, because if you just export this file, it's a .py file only. Okay, if the total transaction is the file what you just created. So now if you just export it, so you can see total transaction.py. You are creating a Python file only. Okay, this entire document is looking so fancy because this ID has a lot of plugins. It just make it look fancy, but end of the day, this is a Python file only, .py file. You write Python core program also using this .py file. You use pandas data frame, numpy, scikit-learn, all this framework of Python also you use using .py file. So that means this is also not different. It's just a Python file. But when you start using the Spark's functionality, then you call it as a Spark application. I know it's little bit. Let me make it simplified. So I'm assuming some people are coming from, say, a Java background, or some people are coming from, say SQL background, or some people are coming from, say, testing background. So the point what here is basically, you are a Java developer, you are creating a .java file and you are writing a program to calculate if a number is prime number or not. Then it is called a core Java application, isn't it? End of the day, your application is running on top of JVM, but you are saying it's a core Java application. Now, you started learning new frameworks. Okay, so frameworks are basically to make life easy. In the same application, you can develop using core library, core Java. In the same application, you can develop using some sophisticated frameworks or libraries where some high-level functions has been written. So you don't have to write all raw or very scratch level code. You just need to write very small amount of code. Things will be getting done. That's all. That's basically nothing but the frameworks are all about. So there are different frameworks on Java like Spring, Hibernate, and all this. So the moment you start using the Spring libraries or Spring related code or Hibernate related code, then your Java application is called as a Spring application. Same story, like you are a Python developer, you know core Python, how to create a list, set, dictionary, how to write a program to check if a number is prime number or not. You also know all these things. So you can write core Python program to do all these things. Somebody just give you an assignment. Can you write the code to add two matrices or multiply two matrices? What you will do? You will basically use two-dimensional list of numbers, and then you will write the logic to add two matrices, element wise element. It's a two-dimensional matrix, two-dimensional matrices, and you have to add them element wise. Same thing. What you do? You just imported a library, say NumPy. NumPy has a single line function. You can do a matrix addition. But in normal core Python, you have to write at least some 3-4 lines of code, at least 5-6 lines of code to do the matrix addition or matrix multiplication. Whereas if you're using a library, Python library NumPy, it can be done in just single line code. That's what it's basically all about. Framework is all about. We are saying Python has a library, say NumPy. Python has a library called pandas. Python has a library called scikit-learn, like that. Without any exception, Spark is also same. Don't feel like it's something different you are learning. It's also a library on top of Python. For a programmer, we like programmer. Spark is again another library on top of Python. You are creating a .py file. You are writing the core Python code to multiply two matrices. You are again creating another Python file. You are importing NumPy library. NumPy, NUMPy. NumPy is again another library on Python. You are using that library to multiply two matrices. Again, you are creating another .py file, and then you are writing the Spark code. And WDD, these are all Python programs, but this is the library you use. You call it as that type of application. You use pandas library. You say it's a pandas data frame application. You use NumPy. You are saying it's a NumPy application. You are using Spark. You are saying it's a Spark application. But at the end of the day, these are all Python applications, Python code. Isn't it? So the reason why I just brought that point here. So here also you're not doing anything else. Here you saw clearly in front of you only. When you download this file, it's saying total_txn.py. In the bottom left-hand side corner, you can see this is also py file. So what makes the difference? Like how you distinguish a core Python application with Spark application through the Spark context object. If you see like you are in that particular Python file, you have used Spark related libraries, then it is called a Spark application. So in the documentation side also, they are saying Spark context object is the entry point, is the main entry point of the Spark function. You can simply create a Python and write the code to check if a number is prime number or not. That's fine. But the moment you start using Spark context, then you are saying like you started using the Spark's libraries in your code or Spark related syntax or APIs in your code. It becomes a Spark application. Okay, that's the thing. So Spark context object is the main entry point to the Spark's functionality. The moment you find this keyword in your application, that means you are saying you started using the Spark APIs or Spark libraries or Spark code. Okay, so it is used to create RDDs, accumulators, and broadcast variables. Okay, we'll discuss that all details. We are now starting with RDDs. So Spark context object has multiple functions that enables you, that gives you an interface to create RDDs out of it. Okay, and is it like you have to by heart always? I would say you start by hearting because you will not be remembering thousands of functions. Maximum 20-30 functions you have to remember. But again, if you feel like why I will be remembering, I'm against that. I feel we shouldn't by heart the things, we should understand it. Different people have different thing. So now coming to the Spark context object, you should see there will be a whole bunch of functions and Control F text file. Text file is a function. What it is saying, read a text file from SDFS or local file system available on all nodes or any Hadoop supported file system URI and return it as an RDD of strings. So it's saying Spark context is a class. Okay, like all programming languages have this object orientation concept. Class is nothing but a user defined type. So Spark context is also a user defined class defined in the Spark framework. So frameworks are what? Frameworks are nothing but a whole bunch of classes, functions written for making our life easy to write the same code, same functionality with very minimum number of lines of code. You say like, I will not use Spark, but I will write HTTP program. Nobody stops you. You can write your program. You can write all this multi-threading logic by your own and do all these stuffs. Say you say like, I don't like Spark, I will write my own logic. Nobody stops you. You can write your own logic to create a RDD or RDD new kind of different class, and you can put all functions and you can make use of it. You can do that, but your overall development time will be too high. Like the same application, if a client gives to a person who is a Spark expert, they're taking 2 months or 4 months to implement the application. But if you are not using any framework, you are writing all this code from the scratch, it might take like a year or few years to complete the same application, isn't it? That's the difference. So frameworks are basically to make the things easy and simple. Okay, all these redundant things, it's already implemented in the library. You have to just use it to implement your business logic. Okay, so Spark context class is a class provided by Spark library itself, and it has whole bunch of functions to basically read data from different systems. Okay, it has different functions to read data and create a RDD out of it. So first function we saw is called text file. Okay, text file function is available inside Spark context. So Spark context object by default injected every time you create a notebook, and then you are saying Spark context dot text file, and it creates a RDD out of it. Okay, so here you saw there are two parameters. First one is name. Okay, name is nothing but the file name you provided, and the second, and there are two more other parameters, min partitions and use Unicode. These are optional. Okay, these are optional, you can skip it. Okay, but later you will see in the other examples you are using other parameters, but this name parameter is mandatory. So that's why you write the code Spark context dot text file, and then you pass the name of the file, and it's saying in the description section, it clearly says it reads the data and create a RDD out of it. Okay, What happened? It basically reads the text file and returns a RDD of strings. Okay, it will read the data and create a RDD of strings. This text RDD is a RDD of strings. Okay, so unknowingly we write the code. We never know like what happened in each and every line. Now we're trying to understand like what actually happened in the backend. We said we created a Python file, and since Spark library is already added by Databricks platform itself, so it gives you all this interface to, or all these APIs to write Spark program. So that's like every time you create a notebook, here Spark context object comes by default, and then you used Spark context.text file function and you passed a path here. Okay, this path is nothing but a Databricks file system. It's also distributed file system. If you go to this data section, this data section is nothing but the distributed file system where you can put your data, and this data are distributed in nature. Okay, say you uploaded a 10 GB of data. So the data is broken into multiple 128 MB blocks, and then each block is copied thrice, and then you are reading that data from that particular Databricks file system, and it gives us a URL, and you read that and create a RDD out of it. Okay, Spark context.text file. You give this URL. This URL is a distributed file system. Okay, as the name suggests here in the description, read a text file from HDFS, a local file system available on all nodes, or any Hadoop supported file system URL. Okay, so this Databricks file system is also a Hadoop supported file system. So you read the data and created a RDD out of it. Anybody having any query on this? Sai, Sanjo, Manjunath?
No, Siddharth. No, Siddharth.
Ashutosh, Adim?
No, Siddharth. I'm good. I'm good, Siddharth.
Okay. Okay, cool. So we just created a RDD out of it. Transaction RDD is basically a RDD, and that RDD how did we create it? By reading a Hadoop supported file system called Databricks file system, and there we have uploaded this file, and it created a URL in this way, and we are reading that and creating a RDD out of it. So that means this transaction RDD is a fault tolerant, immutable, partitioned, distributed collection of JVM objects. The JVM objects are nothing but strings. Okay, each record is a string, and it's fault tolerant because it's over Databricks file system, which is a supported distributed file system, and it's immutable. You won't be able to modify this data. Every time you apply a transformation, you create a new RDD. It's distributed. Here, distributed doesn't applicable because it's a single machine only. But if you take the paid one, you can create a multi-node cluster, and there you can see it's a proper distributed. But still, it is partitioned. Okay, because same computer can have multiple partitions. Okay, we'll see that shortly. So when you read the data, it is having a certain number of partitions. Okay, by default, but you can control the number of partitions also. Okay, so first, how to create RDDs. The first point was by reading data from external sources. And the second one is basically by applying transformations to existing RDDs. Okay, we saw this data is having the first line as the header. And in order to do any computation, we have to first get rid of that header. Okay, so for that, we are writing the filter function, filter transformation, to basically remove the header. Okay, so that means filter function should be available inside Spark context object or RDD. And guess? Anybody? It's actually called on top of RDD, so it should be actually available on RDD.
RDD.
So let's see RDD, what the definition it talks about. Yeah, PySpark.RDD, the first one. So what it is saying, a resilient distributed data set, the basic abstraction in Spark represents an immutable partition collection of elements that can be operated in parallel. Okay, so it has just explained in its own words. Okay, and inside this RDD, that should be a function called filter. Okay, you can see filter is a function. Returns a new RDD containing only the elements that satisfy a predicate. Okay, returns a new RDD containing only the elements that satisfy a predicate. Okay, so filter is, these are called transformations. We'll discuss that in details, like what is transformations and all. But for now, so filter is a function available inside RDD. It returns a new RDD containing only the elements that satisfy the predicate. Predicate means this function means almost all functions are higher order functions you will see inside. So filter function, it takes another function as a parameter. Okay, so filter f. So that's why you saw we called filter, and inside filter we passed again another parameter, isn't it? We called filter a transaction RDD what we created in line number 1. Then you call dot filter. Inside filter you pass this function called remove header. Okay, inside that transaction RDD you called filter, and filter you called remove header. Okay, remove header is a function and it's saying it's a predicate. So what is the definition of predicate? Anyway, function, what's the definition of function? Anybody? Tausif? In any programming language, how do you define a function? It's nothing but a reusable piece of code, isn't it? It's a function is nothing but, I think Tausif, your voice is not coming. Yeah. So it's basically a reusable piece of code. Means, for example, you want to check if a number is prime number or not, and that thing you want to do it repeatedly for 1,000 numbers. So better you create a function is prime number and then you call it multiple times. Exactly same thing. Okay, so filter is also a function whose job is to basically remove unwanted records from your RDD. Okay, and that means, and it's taking a function. Inside that function will decide which records should be retained and which functions should be discarded. Okay, and a function which returns a Boolean value is called predicate. Okay, so inside filter function we are passing the predicate. Okay, remove header. Okay, remove header will return true or false. For those records for which it will return true, those will be kept, and for those it returns false, that will be discarded. Okay, so that's why we have written a function remove header. Okay, every function is very well thought. It's not like any random function has been written. So think in this way. So filter function called on top of this RDD. This RDD is a collection of billion record. So you are calling filter function on that. So filter function will keep on iterating through each and every record of this RDD. Filter function will keep iterating for the whole billion records, and it will apply this function on each and every record. Think in this way. RDD is a distributed collection. It's a huge, giant distributed collection having multi-billion record. You are calling a function on top of it. That function will keep on iterating through each and every record of that particular RDD. It will keep on iterating through each and every record of that RDD. And then it will apply this highlighted remove header function on each and every record. Okay, the first record is the header. It just checked this string not in this, it returns false, so it will be discarded. Then second record is actually your data point. That data point not in this, then it's true, so it will be kept. For the third record, it's actually a data point not in record. This string not in record, true. So only for the first record, all these records will return true. Only the first record will return false. Okay, first record will return false. Rest of the all records will return true. Okay, so transaction RDD.filter, then you are passing remove header. So in this way, in this case, like you will be getting cleansed RDD, and this RDD is nothing but it's a RDD of this cleansed RDD is a RDD of strings. Okay, and that RDD of strings are derived from the transaction RDD.filter. So filter just discarded the unwanted record. Here only one record, that's the header, and the rest of the records are kept. Okay, all these functions what you are seeing on top of RDD, these are all iterative in nature. Okay, and most of the functions are higher order functions. What do you mean by higher order function? So in functional programming like Scala, Python and all, higher order function is nothing but a function that takes another function as a parameter. That is called higher order function. A function that returns another function as a parameter is called higher order function, or a function returns another function as a return type, that is also called a higher order function. Okay, all transformations are kind of this. These are higher order functions. You call map, filter, group by key, reduce by key, and you pass again another function, the actual business logic as a parameter to that. Okay, as a parameter to that. Okay, so these are basically called higher order functions. So you applied the filter function here, and filter function just iterated through each and every record of this transaction RDD. For the first record, it returns true. For the false. For the rest of the records, it returns true. So the first record discarded, and the rest of the all records are kept. And it end up creating a new RDD called cleansed RDD. All right. So on top of transaction RDD, you applied a filter transformation, and you end up getting another RDD called cleansed RDD, which is having -1 record. Like suppose the total number of records was 50, so now it has 49 records. Okay.
Siddharth?
Yeah, please.
Yeah, so just one question. So these functions like remove header function. So do they need to be an RDD function, or like can it be like a normal Python function as well?
It's a normal Python function only. Remove header is not a RD function. It's just you can give any name. These are all user defined function, isn't it? Because this is the syntax to create a function. Def keyword, function name, list of parameters, return type, and then the function body. You defined it by your own. But see this filter function, you didn't define filter function. You just used it here. Map function, you didn't define the map function. You just used it here. It's available inside the RT class. Only the inner function, what you are passing, that's the function you are defining. That's the business logic. Here, this data is having pipe delimiter. So you are writing, here this data is having this header. Maybe you will get another data having another header. Maybe in another data set, you have some unwanted transactions, you want to remove it. So this business logic will vary data set to data set, scenario to scenario. This is always a custom logic you are writing by your own. But the filter function is fixed. It's available inside the RDD class, just we saw. Right? So filter function takes a predicate and it decides which records to be kept and which records to be discarded. But how to basically decide which records to be kept and which records to be discarded, that you as a programmer has to explicitly instruct it. You have to say like on what basis I want to discard the records. So that logic you have to pass. And for that, you are writing a function and you're passing it here. Right? That's what.
Okay.
Anybody having any other queries on this?
Siddharth, why do we need to space before writing return?
Yeah, that's basically a syntax of core Python. So every time you return something, return. So you can see this maroon color. These are basically keywords. Def is a keyword. Return is a keyword. So this is a syntax to define a function. Def keyword, function name. Within parentheses, function name here is ABC. Within parentheses, you have to mention the list of parameters. Okay, you can give anything, XYG, A, P, anything you can say. I'm saying record, REC record, colon. Its data type is str. Okay, Python has a data type called str to represent string. And arrow operator, return type boolean. Okay, you are returning boolean value here, isn't it? Like that. So then inside that, you can write a whole bunch of lines of code. And here we have a very simple function you have written, that is a return statement, and you are writing this logic. Okay, if this string is in this particular record, then returns true or false. Okay, for the first record, this will return false. Because first record itself, this transaction ID, pipe, create time, pipe, amount, pipe, customer ID, like that. The first record is this. We are saying this record not in record. It's false for the first record, but true for the rest of the records. That's the syntax. Okay, return space a statement that returns boolean true or false. Okay, so then you pass this function inside filter, and this filter function created a new RDD, because we discussed how to create RDD. First one is basically by reading data from external sources. Second one is basically by applying transformations to existing RDD. So here filter is a transformation, so you end up getting a new RDD called cleansed RDD. Got it?
That's a syntax simple.
Yeah, that's the syntax, normal Python syntax. Okay, just start exploring on Python basics like how to declare variables, loop, if-else statement, functions. Anyway, we'll be discussing, but parallelly you also start exploring. Okay, because like we will be using Python extensively. So I would say like everybody start building some basic core knowledge on Python. Okay, but anyway, we have 4 sessions on Python post this RDD part. Okay, but nobody stops you. You can start learning parallelly also. Okay, so post that, we after just cleanse the data, we have to basically get the customer ID and transaction amount. We saw the third field and second field are, sorry, third and fourth field are basically customer ID and amount. So we applied a map transformation as you have discussed last session, I think last session. So map is a function, is a mathematical term. That's basically map means mapping from one format to another format. We discussed about that example f of x, right? F of x transforms or map x to y, x equal to 1, y equal to, y will be something else. Basis the expression, say x square plus 2x plus 3. So you put the value of x and whatever the value you're getting, so that will be the y value, isn't it? So like that. So map is a function that maps records from one format to another format. Here, each of this record, what you saw is basically a string. Each of the record is basically a string you saw, like this line. And from this, we want to get, say, customer ID and amount. So that means each record will be transformed from string to a key value pair, that is account number and amount. Okay. So here it's a plain string delimited with tilde, but out of which we want to extract this particular element and say this particular element. Okay. So this is called mapping. You're mapping strings to only 2 fields, that is account number or customer number and transaction amount. Okay, that's the logic. So that's the logic. So that's basically, that's why we are calling it as map transformation. Just remember, map is a very, very common transformations we always use. Okay, every complex transformation has been asked to you. You have to break it into multiple steps. Each step, most of the time, it's a map transformation if you are solving it using RDD. So map function, again, it should be available inside your RDD class. Control F, map. See, one good thing you can see, if you remember map function, by default, you remember 3 more functions because they are very similar. That's how basically this API has been designed. You remember the syntax of map. You will be naturally remembering map partitions with index, flat map, another 4 functions like that. Very, very similar. You remember group by key. So there are another 4 or 5 similar functions: group by key, co-group by key, reduce by key, aggregate by key. All are similar with slight difference. Okay, that's basically that's one of the very good point many Spark developers like. So the API has been so friendly, so naming conventions they have used so nicely. Means if you remember if you try one function, one transformation, you write the code. So naturally you will remember another 3-4 similar functions. Okay, like that. So you're saying customer RDD, so is equal to cleansed RDD.map. Okay, map function, we didn't see the description. What is the description it says about? It says map function returns a new RDD by applying a functions to each element of that RDD. Okay, so you can see F is the first parameter, second parameter is saying preserves partitioning. All these things we'll discuss in details. So what it is saying means, as the name suggests, suppose your RDD is 10 partitions. It's saying after applying the map transformation, you want to get the same 10 transformations, or let Spark decide what's the optimum number of partitions it should keep. Okay, like that. Okay, here we are not using, we are simply passing the function here. We are simply passing the function here. So, so what we are saying? We are saying cleansed RDD.map, and inside that we are passing a function called get amount RDD. Okay, get amount RDD, what it does, it basically split each of this record. Here you saw you pass a parameter record, and what should be its data type? It should be str only, right? And what should it return? It should return tuple of, what did it return here? Tuple of I think int comma, no, not int. What is customer ID? String, right?
String comma string.
String comma integer.
String comma float, you say. Actually, we did a mistake here. It should return float. The second parameter shouldn't be a string. That's why you're getting all our string only. Amount shouldn't be string, right? So you should convert it to float. Isn't it? So what you said, you splitted each of these records through this tilde, and you extracted the third index and the second index. Second index again you converted to float, and then you returned it. Isn't it? Then you returned it, right? That's how you did it here, right? So you yeah, now you can get, you are seeing some less result. Earlier it was string, so it was just concatenating. Plus operator on strings just concatenate the strings, isn't it? So right now what you did, you applied a map transformations to map the string version of the records. Okay, string version of the records to a couple of two elements. First element is a string and second element is a float. Okay, so string is nothing but this account number, and float is nothing but the amount. Okay, like that. This is what the map function is all about. So post that, you are applying a transformation called reduce by key. Reduce by key is also another function. You can just search. You might be wondering like how I will be searching, right? That's again very easy. Once you start writing some programs, you'll be familiar with the wordings, say reduce, map. Basis that you can search. Okay, means reduce means aggregations. Here in distributed programming, reduce means aggregations. Here also similar story. You see reduce function, reduce by key, reduce by key locally, multiple functions. All are doing similar thing, very slight difference. Okay, so these are the good things. Like you remember one function, actually in the backend, you are remembering multiple functions. Okay, so reduce by key function. Let's see the description what it says. Merge the values of each key using associative and commutative function. Commutative reduce function. Reduce means aggregate function. So map and reduce, these are two mathematical functions. Map function is basically always a one-to-one transformation, one-to-one functions. Each input will map to a single output. But here reduce function is basically called aggregate functions. Multiple input, many to one. Many records will be merged as a single record. That's what basically the aggregate function or the reduce function. Okay, so basically that customer RDD dot reduce by key, and we are passing the add function. It takes two elements at a time because it's an aggregate function, right? It will take two values at a time, and it will apply some function which is associative and commutative. Add function is both associative and commutative. You must be remembering your school time, sixth standard. A plus B is equal to B plus A. That means plus operator is commutative. A plus B plus C is equal to A plus B plus C. That means plus operator is associative, right? So these are, so all functions which are associative and commutative, you can pass it here. There are a lot of discussions are there, we'll have in details. So, but for now, just remember you are passing any binary function inside. Okay, reduce by key function, you are passing the add function inside. That add function will keep on summing up the numbers. Okay, and it will give you the results. And then you are calling, this is the final result. Then you are calling take 5 to get the first 5 results as a list. So you're getting the first 5 customer ID with their total sum of amounts. Okay, any queries on this map function and reduce by key function? Ram, Sai, Manjunath. Yeah, please.
In a reduce by key function, and we have to only one key, or we can take a 2 keys. For example,
no, you see this N1 and N2 are not keys. Keys is written here itself. Suppose you have two customer IDs, customer ID C1 and C2. but C1 has done 10 transactions and C2 has done 5 transactions. So what this reduce by key will do, no? It will basically keep on sending values associated with each key at a time.
No,
So for
no.
C1,
For example, in customer ID RDD, we have two keys like customer ID and product ID and the amount.
yeah, you can do that. That's anyway. Means that's what you decide. So here you can see this is a pair having key as the customer ID and value is the amount. Here you can just keep a key as again another tuple that's having customer ID comma product ID or customer ID comma date or customer ID comma month, like that. You can use composite key, composite value, everything is allowed. In fact, there are a lot of examples there. When you just scroll down, sorry, there is a part 2. Part 2 is there. I don't know where it went. Is that in the text tab, right? So you will see like there is a file called this file name. So there are all these examples are there. We'll discuss that in details. Okay. So on pair RDD, we have multiple such examples which talks about how to apply aggregations at single key level, composite key level, how to apply aggregations on single value or multiple values. Okay. Suppose this is transaction amount. You have also transaction count. And you want to sum up the transaction counts as well as sum of the transaction amounts. Both can be done. Okay, so all these things. Okay, so here N1 and N2 are integers. Suppose assume like your values are of composite values. So N1 is a tuple of 2 integers, a tuple of 1 integer and 1 float. Okay, similarly, you will be summing up each and every individual elements separately, and you'll be returning a tuple. All these things are there. Okay, we'll be discussing in this. We will be discussing in detail, but this is a very simplistic version of the data transformation. Any other queries? Sanjog, Tausif, Adim, Nagarjun.
Yeah.
Siddharth, nothing.
Returning, it will check for each and every record, right? Header. Instead, we don't want to. We have to do only for only the first header. Remove and start data processing. Then
first step we just remove the header. Okay. First step we just remove the header. Second step we extracted key as the customer ID and value is the amount. So we have a whole bunch of records having each record is a tuple. Tuple is a collection of heterogeneous type of elements in any programming language. So reduce by key takes 2 records, say 1, 2, 3 ABC 1, 2, 3. Just take 2 record and the values is you can see 1.23 and here it is 2.36. It will send these 2 values and it will get the sum. Then the sum and 42.13. Then the sum and 160.91. Then the sum and 27.19. Then the sum and 145.98. Like that, it will keep on sending pairs of values to reduce by key function, the inner function add, and it will keep on summing it up. Then once this is finished, then it will take another key. Then it will see, first time it will send 223.16. Then the sum and 20, then the sum and 78.77, then the sum and 93.71. Like that, it will keep on sending 2 values at a time and it will keep on aggregating. In this fashion, it will get the total amounts for each and every key.
Okay. The first one, Siddharth, like you said, it will loop for each and every record, whether the header exists or not, right? That one I'm saying. Like header will be at the starting only, right? Once we remove, it should not iterate for other records also.
Once in the first transformation you saw in the filter function, we removed the header. Now you have only 49 records. So it will start from the record 2 only. Record 1 is no more associated with that activity.
Okay.
Your first record itself is the data point 1, 2, 3 ABC 789 means instead of record 1 here. So now what happened? Like this record got removed. Now you have record starting like this. Okay, like that. All transformations will change the complete shape of that RDD and get a new RDD altogether.
Okay.
and like that. Okay, we'll discuss further more details tomorrow. Okay, so I have to wrap it up. So we'll discuss again tomorrow. Okay, start going through all this. Spend some time. Okay, if you really spend some time in the beginning, so you'll be really comfortable and it will be easy for you to craft all the concepts. Okay, don't keep a lot of backlogs. Just finish it in the same day itself. Okay. Thanks everybody. Then really appreciate your time in the morning. Bye bye.
Thank you, Sid.
Thanks.